Good evening, everyone, and thank you for joining us for tonight's clinical webinar, Improving Cataract Surgery Outcomes with the Oculus Pentacam. Before we get started, I'll point out that you have a text box on the right side of your screen for asking questions, and I'd encourage you to ask questions, and we'll have a short Q&A session following the presentation. Our speaker tonight is Dr. John Shamas. Dr. Shamas is a clinical professor of ophthalmology for the Keck School of Medicine at USC. Dr. Shamas has hundreds of publications, including a hardback book titled Intraocular Lens Power Calculations, which is a how-to guide to cataract surgery dedicated to improving patient satisfaction. He is a regular lecturer at the American Academy of Ophthalmology and the American Society of Cataract and Refractive Surgery. It is an honor to have Dr. Shamas here tonight to share his experience with the Pentacam and IOL calculations. So without further delay, I'd like to welcome Dr. John Shamas.
Thank you very much, Chris. Can you hear me okay? Welcome everyone to this webinar on the Pentacam. Like many of you, I'm a clinician primarily, and we run a private practice in the Los Angeles area. And our main goal doing cataract surgery is how to improve cataract surgery outcomes. And I've been using the Pentacam for the past few years now. And I would like to share with you my feeling about the Pentacam and the Pentacam AXL and how I use it in my private practice, and hopefully it can help some of you. Okay, this is my financial disclosure. I don't know how many of you are familiar with the Pentacam, but the Pentacam is a non-contact optical system designed to image the anterior segment of the eye. It uses a Scheimpflug camera to produce a three-dimensional analysis of the anterior segment. Recently, the Oculus company came out with the Pentacam AXL. I understand that it's not FDA approved in the United States, but it is commonly used in Europe and other places of the world. And the Pentacam AXL, it kept all the anterior segment scanning information, and it added a new feature. Basically, it added how to measure the axial length and to calculate IOL power, just like what the IOL Master does. So you can have two units in one. Let me tell you about the Pentacam reports. This is what you print out from the Pentacam. The most common one that they show you in advertisement and that many people like to look at is this anterior segment imaging with the 3D imaging and a very nice computer program image that you see here on the bottom left side of the screen. And on the right side, you see this one is a corneal thickness, but you can change it to any map you would like to look at. And it gives you also a cross-section of the anterior segment of the eye and of the lens of the eye primarily, with some changes in here on the right side of it showing the cataractus changes and its location within the lens. My preference really goes to the cataract evaluation printout. The cataract evaluation printout is more in line with what I want to know for the cataract patients. It gives you a map of the sagittal map. We'll go over these maps a little bit later in the lecture. And it gives you the total corneal refractive map, and it gives you a corneal thickness pachymetry changes in here. It gives you the cross-section of the eye. You can look at the angle, you can look at the lens, and changes within the lens. But of most important to me is this square right on the lower right part of the printout. And let me put it in a larger way. And here you can see what I look at in this square. It gives you the SIMK. The SIMK is very close to the K readings that you take with the IOL Master or the LensStar or any other keratometer in here. That's from the front segment of the eye. It also gives you the total corneal refractive power, and we will talk about it later on, especially for the astigmatic changes and that you look at. It also gives you the difference between them if you want to know. And looking at the total corneal refractive power, it gives you the changes at the center, within the 1 millimeter, the 3 millimeters, the highest, the lowest. I don't look much at those. But you look at the lower part in here. It gives you also a total corneal astigmatism with a wavefront analysis. And of most importance to me is the spherical aberration, the Z440 in here, this number, and the total high order aberration, which is this one in here. And it also gives you measurements of the anterior chamber depth, the corneal diameter, the pupil diameter, and at the pachymetry, it shows you how much it is at the apex or the thinnest, and information. But for me, it's the spherical aberration in this one that are very important, and then the total corneal refractive power with the amount of astigmatism in here that is important to me. Now, a new addition to the report is the fast screen report. And the fast screen report, it looks at different values from the anterior segment of the eye, like the chamber angle in here, anterior chamber depth, and the chamber volume, and the cornea, the thinnest, the maximum, the minimum, all these changes. And you can see a red curve and a green curve, Gaussian curve. The green Gaussian curve is the normal values with their 2 standard deviations, and while the red curve is the abnormal values and the 2 standard deviation. And then you can see within them where the patient's eye stands. Like in this one, the chamber angle is way on the green side within the normal side. However, if you look, for example, in on this side in here, which is the back elevation, you see that the back corneal elevation is on the red side and not on the green side. And that's on the abnormal side. So in one screen, instead of going to multiple screens to look at each one separately, this one screen allows me to look at all the characteristics of the specific eye under study. Of main interest to me really is this last line down in here. And this is the Berlin-Abrosio ratio. And if it is, if it is in the red, it's abnormal, and that means highly suggestive of a keratoconus. And I think these days, especially if we're going to put toric implants inside the eye, it becomes important to know if the eye has a keratoconus or is suspicious of a keratoconus. And there is another ratio in here for the keratoconus, and you see that it is in here between the red and the yellow, also highly suggestive that this eye has a keratoconus. Now, in a flagrant case where you can see the keratoconus and you know it is a keratoconus, it's not a problem. However, in many cases, you really don't know. You see an amount of astigmatism, but it could be a keratoconus form first or different changes, and that screen report in here is very helpful in discerning these changes. Another new item that they have is the corneal optical densitometry, and really it looks at the thickness of the cornea and of the changes, in the average and in the center portion. This is between 0 and 2 millimeter, and this is more at the periphery between 2 and 6 millimeters. And you can see that in this specific patient, the thickness of the cornea is in the abnormal side, and that's because of corneal density in the cornea. And beside the fact that it gives you the information, I think it's nice to have a documentation of these changes. And this is the literature where it was taken from. And if you like to look at in pictures, it gives you also the corneal optical densitometry in a screen like this, like you see it with the maps in here, hard to read, but you can see the picture, the actual picture of the cornea with the changes in the center, with all the measurements of the thickness in different areas of the eye. Another new item that they have is an overview image with visible blood vessel. And we'll talk about it a little bit later when we talk about choosing the axis of the astigmatism when we do put a toric implant. And by taking this picture, you can see all the blood vessels in here, and you can use one of them as a reference for the placement of the toric implant. Now, I know that the AXL is not available now, but let me tell you a few words about the axial length measurement on the Pentacam AXL. The optical biometry is based on partial coherence interferometry, just like the IOL Master 500. And the beam comes in, it's split, and it gives you the measurement of the length of the eye. The menu gives you choices when you do that, and the two most important part that I found is the force alignment, where the axial length measurement is only activated if the patient is fixating. Otherwise, you are prone to get a erroneous measurement. And the green image, it's on all the time, where the iris image that is used by infrared and green LED, and that's what makes the blood vessels visible on the picture that you saw. And this is a printout of the axial length measurement, and you can see the peak of the retina in here, and that gives you the axial length measurement with the pictures that you see on the right and on the left. There are some facts about the measurements and the calculations. The axial length and 3D measurements are taken in succession on the same measuring axis. The corneal apex is used as the reference point. The eye motion during the imaging process is detected with the pupil camera and corrected during the calculation process. The 3D model of the anterior segment is calculated via ray tracing. Thus, you avoid the optical distortion. But most importantly is, no matter how they measure the axial length, is how does it perform? I had the chance to do a measuring 3 eyes with cataracts that we measured them with the Pentacam AXL and with the IOL Master 500. I have many more cases now, but we have not analyzed them yet. But these are on the first 31 of them. The average axial length, the average one was 23.76 with both units. That means the arithmetic difference was 0, plus minus 0.04. I like to always look at the median absolute difference. And the median absolute difference was 0.026. And this is the range, minus 0.09 and to 0.04, which is less than 1/10 of a millimeter. And if you look at the IOL power calculation with the machine, they were all within a quarter of a diopter from the calculation done with the IOL Master. And this is comforting to know. Now, the most important is the Pentacam started with measuring the corneal power. And I would like to spend a few minutes explaining to you what are the different screens that you see and about measuring the corneal power. If you want to think theoretically, the true power of the cornea is the addition of the power of the anterior surface of the cornea and the power at the posterior surface of the cornea. The anterior surface, as you know, is a positive value and the posterior surface is a negative value. However, in actuality, keratometers, they only measure the radius of curvature of the anterior corneal surface, and they convert it to diopter using an average index of refraction of 1.3375. This index of refraction is what we use in the United States. In Europe, they use 1.332, and so this is why when you read some articles with the index of refraction, you have to make sure that it is the same index of refraction that is being used. And this is the formula. It's a very simple formula to measure the power of the cornea. Now, the Pentacam allows measurements of these K readings from 3 different maps. The first map is the sagittal or axial power map, the true net power map, and the total corneal refractive power map. So these are the main 3 maps that you see. And to complicate things even more, these K readings can be taken at the 2, 3, 4, and 5 millimeter rings, or at the 2, 3, 4, 5 millimeter zone. That means the whole zone is being measured. And it is, you can choose these items if you want to do some studies on that. Now, let me explain each one separately so it can make it clearer in your mind, and then we'll see why one is more important than the other. The sagittal or the axial power map, similar to the SIMK, is a Placido-style map of the front corneal surface. The K readings, I call it KF because it's the front, are derived from a simple conversion formula that I showed you. Is the index of refraction minus 1 divided by the radius of the anterior surface of the cornea. And this is what these values stand for. How about the true net power map? The true net power map is the true value of the cornea. And it is the optical power of the cornea by using the measurement from the anterior and the posterior corneal surfaces. And for that reason, on the front part, the index of refraction is 1.376 minus 1 for the air divided by the anterior radius. And on this side is 1.336, which is the aqueous, the index of refraction of the aqueous, minus 1.376 for the cornea, and divided by the radius of curvature of the posterior part of the cornea. And that gives you the total net power of the cornea. The most interesting one is the total corneal refractive power. Now, it's true that the power is the front and the back. However, the total corneal refractive power uses ray tracing to calculate the corneal power. What does it mean? It means that when parallel light beams are refracted at the cornea, they are bent according not only to the correct refractive indices, depends also on the slope of the surfaces and the exact location of the refraction. That means this measurement could be different, whether it's at the 2 or 3 millimeter or 4 millimeter or whatever distance away from the apex of the cornea. And that yields the total corneal refractive power value. This is actually the way our eye function by bending the lights on the cornea via ray tracing. And then each one of them will give you a map like this one. This so happens the total corneal refractive power map, and it shows you the different values at different places with the different diameters that you want. You can pick up the one you want, and it can show you the amount of astigmatism and the axis if you like to look at it in that manner. Now, if you want to look more into it, you can look at the power distribution. As I said, it could be either the zone or the ring, and it could be either at the apex or at the pupillary size. Most of the time, it's the ring that's more important than the zone, and the apex is more important than the pupillary area. And then you can look at all these values, whether it's the sagittal front, which is like the SIMK, the true net power, or the total refractive power at the 1 millimeter diameter, 2 millimeter diameter, 3 millimeter diameter, or 4 millimeters diameters. Now, we know that the Pentacam displays different corneal maps, And what I was involved in a few years back is I wanted to see how do these readings differ from actual keratometry, and can we use these measurements to improve IOL power calculations. And one of the residents that worked with us, I made him write the article and do a lot of the calculations. They were very elaborate, and it was published in the American Journal of Ophthalmology a couple of years ago. The bottom line is, on these cases that we compared, the average K readings by the IOL master was 4368, while the average SIM-K on the front part was 43.76, which means the K readings taken from the Pentacam on the front side, the SIM-K, is approximately a little bit less than 1/10 of a diopter more than the IOL master. If you look at the true net power, it was 42.45, and it was more like 1 diopter and a quarter less than what the IOL master measures. Remember, if you have used the European 1.332 index of refraction instead of the American 1.3375 index of refraction that most people are using now, the values could have come closer to these ones. And the refractive power was 43.24, which is a little bit less than half a diopter less than what the IOL master or the SIM-K will measure. Now, if we plug all these K readings into the formula using Huygens formula, and you average, the way to do it is you average the mean arithmetic error to 0 in all of them by adjusting the constants, and then you look at the standard deviation, and you look at the standard deviation did not change by much. If you look at the median absolute error with each one of them, you will notice that with the refractive power K, we did a little bit better, and we had a little bit more cases within ±1 diopter. However, the number of cases that we had was relatively small, and statistically it did not show a major difference. So the bottom line really is, none of you is going to probably use these values to do IOL power calculations, but if people are to do some studies on that, if you are using the SIM-K, you just add 0.07 to the A constant. If you are using the true net power, you subtract almost a diopter, 1 from the A constant. And for the refractive power, we subtract 0.40 from the A constant. Now, it also does IOL power calculations. As you know, the SRKT, Holiday 1, and Hafer-Q formulas require the axial length and the K readings to calculate the IOL power. The Huygens formula requires not only the axial length and the K readings, but also the anterior chamber depth. The nice part about what they did with the Pentacam AXL is it measures all these parameters with one instrument, and it does personalizes the constant for you automatically, the A, the SF, and the PACD in the machine. Now let's talk a little bit more about the IOL power calculation in treated eye. And we are going to talk about what using the regular Pentacam, not necessarily the Pentacam AXL, and what the Pentacam AXL does in addition to that. So we are all performing cataract surgery on treated eye, post-RK and post-LASIK, and these are tough eyes to deal with. The Pentacam AXL has no special IOL formulas for the treated eyes, just copied from the literature. They actually went by and customized all these formulas specifically for the Pentacam AXL. Let's talk about each one separately and tell you what I do. Pentacam K readings for IOL power calculation after RK. Let me tell you, after RK is by far more difficult than any other LASIK or PRK or any other one. It's because these K readings fluctuate and they're very difficult to gauge. I personally get excellent results. I take the Pentacam K readings from the 2 or 3 millimeter ring on the SIM-K, and I use it in the regular Huygens formula. Please do not use the Huygens L formula, is because the Huygens L is for the LASIK cases. The regular Huygens L is preferred over the SRKT and the Holiday 1 and the Hoffer Q, is because it does not depend on the K readings to estimate where the lens ELP, which is the estimated lens position inside the eye, is. Let me show you an example how the Pentacam did help me on one. This is actual cases from my cases. This is a patient with after RK, and the IOL master gave me 2.4 diopter of astigmatism. I got excited to put a toric implant to correct it, and the average was 36.3 on the case. But the SIM case, when I looked at it more carefully, it shows you that the amount of astigmatism is 0.6 diopter only, and not 2.4. And the average K is 35.3 and not 36.3. That would have made not only a big difference, more hyperopic eye, but I would have also corrected the wrong amount of astigmatism. So in these cases, I mean, if the two values match, you're in great shape. If they don't match, I would look more specifically about the values that you get from the Pentacam. And what the Pentacam does also is they did a study with Dr. Potvin and Dr. Hill, and they published it in the Journal of Cataract and Refractive Surgery. And they looked at the different cases from Dr. Hill's cases, and they looked at the power at around the 4 millimeters, and the mean value, at the 4 millimeter zone centered over the pupil, and the thickness of the cornea. Now, you don't have to think about all these things because the unit will do it automatically for you, and it will give you the answer. Now, after LASIK is another problem that we all face, and I don't know if some of you know, but I wrote a formula on the no history formula for post-LASIK cases. And as you know, the LASIK flattens the front surface of the cornea and does not touch the posterior surface of the cornea. And that creates a problem in the calculations. I'm not going to go into much details into that, but let me show you what the Pentacam people did. They used my formula, and Dr. Potvin and Dr. Hill went by and they reviewed their cases. They made some adjustment, and they found out that they can get a much better result with a tighter connection around the 0 value in here, using some measurements from the Pentacam and using my formula along with it. And I think this was published recently in the Journal of Cataract and Refractive Surgery also. Now, what I like about the Pentacam also is I got burned a few times on keratoconus eyes and the measurements from a keratoconus eye. And the keratoconus, as you know, will give you, I mean, it differs from patient to patient, but look at this one. It is very steep on the lower part, but not in the center. And sometimes it creates a problem in calculating these patients come to surgery for cataract surgery. You would say, why don't you do corneal transplant or do different things for these patients? Not everyone wants it. They lived with it for many years with a certain amount of astigmatism, and they don't want to have anything done for the keratoconus, and they develop cataracts, and you have to accommodate these patients. This is an actual case that I had not too long ago, where the IOL master gave me a measurement of 45 over 52 and an KM48 and an astigmatism of 6.75. And this did not jive with the amount of astigmatism that the patient was having in his glasses. And on the Pentacam, the SIMK and the total corneal refractive power showed that the amount of astigmatism in the center was only 3.5 diopters. And in patients like this, I would have made a big mistake if I attempt to correct the larger amount. I don't think I can either. Now, talking about the astigmatism, you know, the precise astigmatism calculation is becoming a major issue now that we are using toric implants, and many patients, all patients I should say, are paying cash from their pockets. No matter how much you're charging them, they feel like when they're paying you cash and you owe it to them to give them the correct to do a surgery whereby they're gonna end up almost plano for distance. So then measuring the astigmatism in these eyes become quite important. Now, what's the difference? The keratometer, including the one in IOL biometer such in the IOL Master on the LensStar, they measure the K readings only from the anterior corneal surface, and they do not take into account the astigmatism produced by the posterior corneal surface. The Pentacam does. And I am pretty sure many of you maybe are familiar with an article by Doug Koch that was done not too long ago, where they showed that the amount of astigmatism from the posterior surface of the cornea is very important to the calculation of the amount of the total amount of astigmatism. So in my opinion, if correcting the astigmatism is part of your surgery, whether it's a toric or by relaxing incision, you owe it to yourself and to your patient to calculate the total corneal astigmatism, and not only the one produced by the anterior corneal surface. And the best way to measure the total corneal astigmatism is through ray tracing. It has been proven again and again, and it's given by the total corneal refractive power map. Not too long ago, there was an article that was published by Dr. Davison and Dr. Podvin from the Wolf Eye Clinic in Iowa about the refractive cylinder outcomes after calculating toric IOL lens cylinder power using total corneal refractive power. And let me go over that study again. It's not my study, it's Dr. Davison's study. And they look at 83 consecutive toric IOL cases. And they took the measurements from the IOL Master. Sorry. And they took the Pentacam total corneal refractive power at the 3mm apex and from the ring. The Acrisoft toric IOL online calculator for toric IOL cylinder magnitude, like we all do probably. And they compared it to the Varian digital marker for surgery at the time of the surgery. There's quite a follow-up, and they looked at compared the actual result with theoretical Varian results. And if you notice that the one with the Pentacam do a lot better in the center and less in the periphery than the Varian. And if you want to look at the numbers, the amount of mean vector difference was smaller with the Pentacam values than with the Varian, and the percentage of cases within half a diopter is higher with the Pentacam than with the Varian. If you go to the 1 diopter, they became almost identical. Although this is fantastic, but I still think this is 55% within half a diopter is really not a optimal results. And we're working on seeing the different values given by the Pentacam to see if that can improve it a little bit better than that. But at the present time, with what we have available, it's amazing that the Pentacam with the total corneal refractive power is giving better results than the Varian. Now, if you have, when do astigmatism, I routinely do a pentacam and I compare all the results. If you have a case like this one, where the IOL master gives you 1.4 diopter of astigmatism, the SIMK 1.5, the total refractive power 1.5, serendipity, you don't have to worry. You know exactly what you're going to do. And actually, these patients do extremely well because all the values go along the same line, and that means there are really not many variations in the corneal power at different points of the cornea. However, if you have a patient like this one, and this is an actual patient, where the IOL master gave me 1.25 diopter, the SIMK was confirmed that 1.4. However, the total corneal refractive power gave me 2 diopter of astigmatism. That's a difference of 0.6 diopter in the amount of astigmatism to be corrected. And that creates a problem what to do. And these are the actual of this case. I use the IOL master case or the pentacam SIMK for IOL power calculation. So the calculation called for a 22 diopter IOL. I personally use the Alcon SN60WF and the Alcon toric implants. But however, to calculate the toric power, I use the total corneal refractive power to do these cases. Now, had I used the IOL master case of 41 and 42.25, and I put them in the Alcon toric calculator, it called for a T3 toric at 170 degrees. If I use the total corneal refractive power case that I found, it called for a T4 toric IOL at 174, very much the same angle. I used the 22 T4 IOL, and the final refraction was plano minus a quarter, axis 180, which was extremely acceptable. And I'm happy I used the total corneal refractive power and the values that I got from that, and I'm using the T4 instead of the T3. Now, the pentacam has a toric IOL calculator in it, especially I think it's a new addition, and it's based on the meridional analysis by my friend Hanbor Pham from Singapore, and where the spherical power of the toric IOL is calculated using the SIM case from the anterior surface, and the toricity of the IOL is calculated using the total corneal refractive power and the surgical induced astigmatism. And it was published in the Journal of Cataract Refractive Surgeries. So the pentacam uses that methodology. And this is the printout from the toric calculator, and you can put in different type of implant and different kind of formulas, and you can program it the way you want, and it will give you a picture of the axis and the power and the way to do it if you want to use this one instead of using the Alcon toric calculator. Now, this is, I think, one of the most exciting thing that they are doing is an overview image and keratometry overlay. And you remember we talked that they take with the green LED light picture showing the different veins and arteries in the conjunctiva in here. And they superimpose the keratometry in here, and you have this one, you can move it in different ways and align it with a vein or a blood vessels of your choice. And so at the time of the surgery, you can say, I'm going to go 10 degrees from this blood vessels, or I want to align it with this one right in here. And if you can locate it in surgery, then you will have a much better idea of where the axis of the toric IOL has to be placed. I admit I've never used it yet, but I'm planning on doing it. It looks very nice. Hopefully it works as well as it looks. Now, one more thing that the Pentacam allows us to do ever since it was put in service is the assessment of the corneal optical quality with wavefront analysis. Now, I don't know if you are familiar with the Zernike polynomial of the wavefront at the different levels, whether it's 1, 2, 3, 4, or different levels of aberrations. You don't have to. What you look at, I don't know if you remember that thing I showed you on the cataract evaluation sheet printout on the lower right-hand side. I look at the total corneal spherical aberrations. In this case, is 0.352. Why is it important? Eyes with spherical aberrations of 0.1 or higher, which is most of us, will do very well with an aspherical IOL. I think the Alcon implant corrects approximately 0.24 or something in that range, and the Zeiss a little bit different, while the Bausch & Lomb corrects nothing of the aberrations. However, if you have eyes with a spherical aberration of less than 0.1, they might do better with a spherical IOL. And I see this one basically in patients with prior hyperopic LASIK. So remember, in patients with prior hyperopic LASIK, the Pentacam can help you in determining the amount of spherical aberration and whether an aspherical implant will be helpful or not. And I look at the high order aberrations, and the high order aberration in this case is 0.146, and if it is higher than 0.35, might not be suitable for a multifocal IOL. And this is especially important in patients with prior myopic LASIK. I honestly did not know that a few years back, and I had a nurse come in, an RN with cataract after LASIK, and she wanted a multifocal IOL, and I obliged. And the vision kept fluctuating after surgery, and it was really not tolerable. And when we did the Pentacam, I didn't have the Pentacam at that time, but afterwards when I did the Pentacam, it showed a very, very high number on the high order aberration, and we had to take her back in and take the multifocal implant out and put a regular implant, and she did very well. So remember, in patients with prior myopic LASIK, if you are planning on a multifocal IOLs, sometimes you can look at the high order aberrations before you do that. So in conclusion, what I have always liked about the Pentacam is that the patient that had prior myopic or hyperopic LASIK, I get better K readings, and I use the wavefront analysis to determine which IOL to use. In patient that had prior RK, I get better central K readings. In patient with keratoconus, I can confirm the K readings in the optical axis and not on the corneal apex. In patient contemplating a toric IOL, I get more accurate total astigmatic values and its axis from the total corneal refractive power map. In patient contemplating a bifocal IOL, I want to make sure that the wavefront analysis is okay with the before I use any bifocal implant. The new Pentacam AXL has become a total screening tool prior to cataract surgery because it combines the two instruments in one. So the Pentacam AXL, just to put a plug for it, it does the optical biometry and it does it well. I love the fast screening report to look at the keratoconus, the anterior chamber changes. It does the IOL calculations with customized formula. It does the total IOL, toric IOL calculations, so I don't have to take from the values from one and retype them in the Alcon toric calculator. and the overview image and keratometry overlay remain to be seen whether it's going to be helpful in surgery. And I am always like the Scheimpflug imaging and the wavefront analysis that's available on the Pentacam. And I thank you for your attention, and I hope you've enjoyed the webinar. I'm open for suggestion and for questions. If you have, feel free to go ahead.
Thank you very much, Dr. Shamas. Very good talk, and we do actually have some questions.
Go ahead.
And just before we start with the questions, I would like to just clarify, and I know you mentioned it earlier, the Pentacam AXL is not currently FDA approved yet, and just to clarify the differences between the current approved Pentacam HR and the AXL, the difference is the AXL does give you an axial length measurement, and it does have a built-in IOL calculator. Everything else that Dr. Shamas mentioned is in the current Pentacam as well. So just to clarify that, and then I'll get on to the questions here. Dr. Shamas, I have one doctor that is asking, do you implant toric IOLs in eyes with asymmetric bow ties? How about with irregular astigmatism? How do you decide the power and axis of astigmatism in these cases?
Actually, I do, but I discuss it very vividly with the patients in advance, and especially those who have a very high amount of astigmatism. I look at the total corneal refractive power. I try to take a consensus from what the patient has been wearing all his life in his glasses as far as amount of astigmatism. I look at the total corneal refractive power for a more accurate measurement of the amount of astigmatism. I look at the wavefront amount of astigmatism, and I try to take a consensus of those. But I discuss with the patient that even if I use a toric implant, he's not going to be just plain or just like that with a fantastic type vision. I tell them that I show them the picture and I show them how irregular it is, and the same with the keratoconus patients, by the way. And if they want to proceed, I tell them that I have no guarantees for them on those patients, but actually they do, a lot of them do relatively well, and they are happy. If I can decrease the amount of astigmatism to a reasonable amount, then I think I would have achieved a good thing for them.
Okay. Thank you. I have another question here, kind of a follow-up question. Which Ks do you use to calculate IOL power in keratoconic eyes?
I try to, I do an IOL master or a LensStar. I have both in different offices. I do that for the measurements automatically. However, I do the Pentacam and I look at the SIMK values, and if there are major differences, then I use the SIMK values to do the IOL power calculations. If they are very much the same, then I leave it alone. That's what I do.
Okay. Another question here. How does the Pentacam compare with the IOL Master in dense cataracts? And I'm assuming that they're referring to the axial length measurement as far as biometry.
Well, I don't know the answer to that. There have been no publications related to that yet. I just did 30 eyes on eyes that measured with the IOL Master. So I did not do measurements on patients that did not measure with the IOL Master. So I don't want to give a false impression that it does or it does not. But the technology is very similar to the IOL Master. So I am presuming that if it measures with the IOL Master, it will measure with the Pentacam AXL, and if it does not measure with the IOL Master, it might not measure with the Pentacam AXL. There will always be one case or another whereby the beam goes through a posterior subcapsular opening, if there are posterior subcapsular opacities, because these are the ones that really do not measure very well with one versus another. So it's hard to tell, but the technology is identical between the two, and I believe until further studies that they are identical in how much percentage of patients they measure.
Okay, thank you. So I have another one here. This is somewhat specific.
Yeah.
Hope you don't mind. How do you approach a case with 11 diopters of astigmatism after PKP and come with Ahmed valve and cataract? Sorry, just reading that word for word.
No, I understand. I mean, the patient had a corneal transplant, I think. That's what he said, PK? Yeah.
Correct.
And Ahmed valve, yeah. And to be honest with you, I mean, he is stuck with a lot of astigmatism. You can correct some of it with the toric. I do not do relaxing incisions. I do not do wedge resections. I used to do them when I was younger. I stopped doing them at the present time. So to be honest with you, I probably will put the highest amount of toric IOL I can use, and maybe after the surgery, I can send him to have either a LASIK, or not LASIK, sorry, a PRK, or a relaxing incisions to correct the remainder amount of astigmatism if you would like to do that. That's the answer.
Okay, thank you. I think we have time for a couple more, if that's okay.
That's fine.
What K values do you use in the toric calculator, such as the Alcon calculator?
You have a choice to use the K readings. Usually you put the IOL master K readings. However, when I do a toric calculation and there is a difference between the total corneal refractive power and the IOL master K readings, I use the total corneal refractive power K readings in the toric calculator, the Alcon toric calculator. However, remember that to calculate the power of the implant, use your regular IOL master K readings. To calculate the toric amount with the Alcon toric calculators, put the total corneal refractive power taken at 3 or 4 millimeters into the toric calculator. That's what I do.
Okay. Thank you again. I have a doctor here that's just asking an opinion question. He says, thank you for your time. And do you think the AXL will replace interferometry from the IOL master?
What the AXL does, it allows you to have 2 units in one. It's going to replace in IOL Master 500. If having 1 unit only that does both of these things together, then the AXL is for you. It's going to do as good a job into measuring the eye as the IOL Master 500. No doubt about it. The first 30 cases, they were very easy to measure. The measurement was very accurate. The difference between them and the IOL Master was minute, to say the least. And once I have more cases, I will be able to evaluate it even more. But it looks like the answer is yes. It will be as good as the IOL Master 500, plus the fact that you have all the Pentacam readings and all the Pentacam additional sheets and printouts that you can have.
Okay, perfect. So I think we have one more question here.
Okay.
Do you favor the Haggis formula for your IOL power calculations regardless of axial length or flatness or steepness of keratometry?
What I do, to be honest with you, there are multiple studies that looked at these formulas. It's like the Highest does well in all of them, while the SRKT does better in the very long eyes and the Hopper Q in the very short eyes, the Holiday one in most average eyes. I automatically print out with the IOL Master, with the LensStar, and hopefully with the Pentacam AXL, I print out all 4 formulas. I print out the Highest, I print out the SRKT, I print out the Holiday one, and the Hopper Q. And I look at all 4 of them. I look at what the other eye is. I look if the patient's second eye, for example, is a -2 or -3. I try to take the value that might prevent the patient from going into a hyperopic post-cataract surgery refraction. So I do take the Highest formula. In most of the cases, the Highest formula is very similar to all the other formulas. In some cases that the doctor mentioned, like very steep corneas, or very flat corneas, or very long eyes, or very short eyes, then the Highest formula gives you a little bit different value. And this is where I look at, for example, in the long eye or a steep cornea, I look at the SRKT and the Highest, and I make my decision which way to go and use it accordingly. But yes, in answer to your question, I like the Highest formula. It has served me very well.
Okay. So I think we'll go ahead and wrap it up from there. I certainly appreciate your time, and it's always a pleasure, Dr. Shamas. For everybody out there that's still listening, if you missed part of the webinar tonight, we will be posting this webinar to our website, oculususa.com. And then if you have any questions, you can always email us at sales@oculususa.com. So thank you again, and on behalf of Oculus, thank you, Dr. Shamas, and you have a good evening.
Thank you. Have a good night, everyone. Thank you.
Thank you.